All right, here we go. His eye level, 1.5 meters above the ground. Where can I put that 1.5? His eye level, 1.5 meters above the ground. Well, I wouldn't call it the height because we got the old 4, or maybe he's got a 5 head. I don't know. All right, above his eyes. All right. Anybody ever heard that term before? Okay. That's a big forehead, huh? All right, 1.5 meters above the ground. He stands 30 meters from the tree. Where's your 30 going to go now? He's 30 meters from the tree. Yep, distance from him to the tree here, 30 meters. From here to here, yep. And now his angle of elevation, the angle of elevation of bird at the top of the tree is 36 degrees. So if you remember when Cam and Will were up here, from the horizontal line, his angle to the bird is 36 degrees. Everyone should remember, angle of elevation. Eye level, horizontal, up, going up. And I need to know how far above the ground the bird is. So I need to find this huge distance here from that bird to the ground. Okay, can you help me out here? Anybody see a right triangle I can draw in? Where is it, Will? Because I have two sides already drawn in.
From the bird.
Yep, to
eye level.
To eye level, bird to eye level. Perfect. So there's my right triangle I can draw in. Am I going to find X right away? No, but can I find a part of X that'll help me out? Sean?
The 1.5 go on the tree. Isn't it horizontal?
Oh, yeah. Hit 1.5. I got a 1.5 here.
Yeah.
Okay. But I need to find this total distance. So what else do I need to find? Which is from the bird down to his eye level. Everyone agree? If we can find the bird to eye level distance, I can add that to 1.5 to get the total distance. All right. Can I use Pythag? 30, 60, 45, 45. Hill Sass? Nope. We're going to resort back to what? SOHCAHTOA, sine, cosine, tangent. What sides am I providing for you? What sides am I providing? 12. Okay. Let me make a comment. What do you mean adjacent? I don't see any adjacent side here. Or do I know that, Emma? 30. Good. All right. Because I didn't have it on my triangle, so people might have assumed that it maybe didn't belong to it. But yep, 30. So that was my adjacent side. And what other side do I have, Emma? I have the Y, which is opposite. All right, this is day 3, right? This should be no big deal. If you need to write SOHCAHTOA at the top, do so. Which ratio can I use? 9. Which ratio can I use here?
Tella or Tam?
Tangent, thank you. The tangent of, we don't use tangent that often, but now we will. 13, no. 13, no. 10.
No.
Jokes, 19. Opposite, so what's opposite? Over. 30, and it's the tangent of 36. I know there are no rounding. Well, darn it, I gave that away. Are we done with the problem when I find this answer? No, I'm not. Why did I ask you that?
You have to add 1.5.
And also what not to do in your calculator right now. Don't round a darn thing, because this is not my final answer when I find this. So I believe I end up getting... There it is, 21.79627584. That's bird to eye level, plus another, bless you, plus another 1.5. And I know there's no rounding directions. I'll make them up here. Nearest meter. Nearest meter. That's what happens when Mr. Carlino uses notes from last year to nearest 10th. Nearest 10th. Okay, good. All right, so nearest 10th, X is going to be equal to, what do we have? 23.3 meters above the ground, that little bird. Or a big bird, maybe. You never know. Yes, Justin, hello.
Could you do tangent 36 equals x minus 1.5 over 30 instead of having a y?
Say that one more time here. Tangent.
36 equals x minus 1.5 over 30.
Yes, you could. Yep. You just and then again, you're doing tangent, because what you ended up doing is really what we did, except all in one proportion. Yep. Anything else, kids? Anything else? All right, diagrams get even better on the next one. Here we go. Look at those guys, huh? Reminds me of some of the fellas in here. Frail. All right. What's going on? Yes, ladies. Good. We good? Too harsh? Okay. All right. All right. Here we go. First time. Angle of depression. Now we're on the top of the building looking down to his friend is a 40-degree angle. But remember how that 40-degree angle is formed. A lot of people think, oh, 40 degrees, I'm looking down right there. No, no, no. How'd you form it, Cam? With the, when you were standing up here?
Oh, yeah.
From your eye, horizontal eye level. So everyone see here, angle of depression, that's that angle right there. Eye level looking down, outside my right triangle. What else do we know? The rooftop, 16 meters from the ground. And his buddy there, John's eye level is 1.8 meters from the rooftop. Got it. What's the distance between his friend and the building?
Wait, is that like that space? What's the 1.8?
That is his eye level from top of the roof to his eye level.
Height?
Yes, or you can call it his height, but it doesn't go all the way up to his head, just his eyes. But okay. And yes, the building is perpendicular to the ground. Here's my issue I need your help with right now. That 40 degrees does me no good. It's not inside the triangle. To use sine, cosine, tangent, I need angles inside the darn triangle. That 40 is not inside, so it's not going to help me out. Can you use it to get an angle inside, though? What are we thinking here? Can we get an angle inside the triangle knowing that angle of depression is 40? Let's think about this. There's two different ways we could go about this. Two different ways. Love to hear any of your thoughts. How I could get an angle inside the triangle knowing that's 40. Amy? Perpendicular, you mean? Well, those two angles there, those two angles do form a right angle. Because the building's vertical, the eye level's horizontal, so they do form a right angle. So what are you going to tell me about the angle next to 40? It's 50, because they form a right angle. There's one way. Will, come on, be there. Be there.
Is eye level and the ground parallel?
Yeah, they are. They're both horizontal. So tell me what type of angles you see up there if those are parallel.
There would be a 40-degree angle where the guy is to the right. Yeah, right there.
Because these are what type of angles? Alternate interior. Nice job. So, whoa, hold on. Let me go with Will's here for a second. He's saying that since they're alternate interior, that's 40. We have a name for that angle, don't we?
40?
What did we just talk about? He's on the ground looking up. That's the what? Angle of elevation. So I'm trying to tell you, angle of depression is always equal to the angle of elevation. Mind's blown, I know. All right? So either way, I know that, but to get depressed, to get to the depression, hey, to get to the depression, to get to the angle of depression to elevation, they're equal to each other. Okay? Everyone good? So it's up to you what you want to do right now. You can keep the 40 there or make the one next to it 50. All right? Two different methods. I'm going to keep the 40 right there just because it's already there. All right, what's the 16 and x on my diagram then? 16 and x. Here you go, 4, the 16. And how about the x? Adjacent, meaning what ratio should I use here? 8?
Tangent.
Tangent. Tangent of 40 equals opposite 16 over adjacent x. And here we go.
Wait, so when you have to add 16 and 1.8?
You got me. I was all fired up with Will getting that whole alternate interior. Yes, I would not. Thank you. I would not use 16. I would use 17.8. Thank you. Nearest tenth again. 21.2 meters. Anything for, yep, Cam?
This is like kind of more like how you like grade it out. So does it matter if you would just do like one long line and write like divide the whole thing by 1040 instead of doing like both sides? Just like when you write it.
Okay, that's fine.
Well, I didn't know like if it
No.
mattered when you.
No, you know why? You know why I do it this way? It's because I've seen multiple choice questions on a Regents exam where it'll say, what's a correct calculation to find x? And all they'll write is x equals 17.8 divided by tangent of 40. So I'm just getting you guys used to seeing something like that, writing it all out. But no, I don't care what you do. No. All right, back to the boat. A little lighthouse action. That's the pictures start getting better. You're standing on the gallery. I never knew that before. That's the top of the lighthouse. Anybody know that? Anybody ever been to the top of a lighthouse? Yeah. Did you know you were at the gallery?
A guy that was when I was doing my nose piercing session, this guy got a tattoo that was like this big of a lighthouse on his leg. But he was like one of those dads that wear like the white New Balance sneakers. And it was really colorful. And then this other lady started
No.
getting on him.
I'm not at that point in my life yet.
Story time.
I'm not at that point. I'm sure I'll get there eventually, but I'm not at that point in my life. No.
Like, doesn't that make you feel better about yourself knowing that you don't have a colorful lighthouse tattoo on your leg?
I get. Hey, to each his own. Hey, if that's what he wanted, maybe it had like some family significance to it. You never know.
No, he said it did.
That's a real question.
Okay. All right. I don't know what to I don't know what to say.
Just gets like a balding.
If he's happy, he's happy. That's what I say. If he's happy, he's happy. All right, here we go. Let's get back to the lighthouse. Standing at the top of the lighthouse, you see the boat at an angle of 20 degrees. That's your angle of depression. So again, standing at the top of the lighthouse, not 20. It's the one that's formed with the horizontal line of sight. That's going to be 20 degrees. Okay. Drill that. And then what else do I know? The lighthouse is 28 meters tall. And the cliff is 45 meters tall. What's the horizontal distance? All right, so the horizontal distance from the lighthouse to the ship. So horizontal distance. All right, do you guys want to go 70 or do you want me to put the 20 at the angle of elevation? 20. Okay. What sides are provided here? What sides are provided? 20, what sides are provided? Again, and they are, yep. This will not be the case every time. Please don't think you've seen a pattern. It's not. So tangent again of 20, and I'm not going to make this same mistake twice. What's my opposite side? 28 plus 45, so yes, 73 over adjacent x. This one have rounding directions as well? Nearest 10th again. .200 point. Meters. Okay, anything else? About 200 meters away. All right, this one's my favorite one of the day. Nope. And the reason is there's no diagram, so I get to come around and critique everybody's drawing abilities. No, I'm watch what I'm about to do up here. All right, trust me. I'm not embarrassed easily here. Angle of elevation to an airplane viewed from a control tower. Ever seen the control tower before?
Yeah.
Okay, control tower is 7 degrees. All right, so let's get a control tower up.
That's beautiful.
Nice.
Okay.
It looks like a sippy cup.
Oh, I'll be around. Don't worry. I'm walking around in a second here to see yours. Here we go. Hammer. Okay, there's my control tower. It sees the airplane at an angle of elevation 7 degrees. Again, how's elevation formed again? How's elevation formed? Looking up, right? So from the control tower, I got a horizontal line looking up towards the plane. And that is 7 degrees. Okay, not from the ground, from the control tower. What else am I given? The tower is 200 feet high. Got it. And the pilot reports that altitude. Now, altitude is from ground to plane. So from the ground to the plane is 5,200 feet. All right, from ground to plane is your altitude, 5,200. Now I got to talk about this one, so just keep your focus for 2 seconds. How far away is the control tower from the airplane? Did you notice in the last problem, I specifically said, what is the horizontal distance? If I want horizontal distance, I will specifically ask like I did in this previous problem. Here, I'm just asking distance from control tower to plane, which I'm referring to as the direct distance. If I wanted the horizontal distance, I would specifically tell you, hey, find me the horizontal distance from the control tower to the plane. Okay? But if that is not there, I'm looking for the direct distance. All right? And then there's my right triangle. What other side can I write in there? I don't know. I know the missing side. Amy? Yep. Yep. How'd you get it? Yep. And then that's how I end up with 5,000 for that side right there. Okay, so you guys decide right now what you want to use. Not bad. Some people just using the old vertical line. That's shameful. Is that like a?
This is airplane.
Is that a? Oh, that's the airplane. All right, never mind. I thought it was the control tower.
It looks like the glove from Glove World in SpongeBob.
And they're just. Is that plane now just flying directly, nose up in the air?
It looks like a boat.
Okay, we're good. Couple trees, couple hammers for the control tower. Not bad. Somebody on the control tower, okay. On top of it. Inside wasn't good enough. Good. A couple of you guys decide to put a UFO on top of your control tower. Not bad. What are you guys deciding? Which ratio are you deciding to use? Sine? Sine of 7 equals 5,000 over x. Yep. You will find that this plane is pretty far away from the control tower.
Pretty close.
I'm just saying.
Wait, that was
How far away did you find?
So that's
41,000,
28.
28 feet.
Good job, you got
I
around.
thought it was then I reread it.
Meters, damn it.
Oh,
Do not convert them. You like my playing, Kyle? Or how?
And they get covered up when we take the quiz and test, unfortunately.
Sotoa.
Oh, I just noticed it was there.
Kyle, what is your plate? It's like almost as bad as that one.
Last one. Last one. Let's get through this last one.
15,006.
Rhombus. As you're drawing this, start thinking about some rhombus properties that you may know, other than all four sides are equal. Let's see. Diagonal AC measures, so A, B, C, D. Remember how we label our quadrilaterals clockwise or counterclockwise. Both are acceptable, just don't jump diagonally. And we are told AC, that diagonal is 80 units long. Everyone find angle BAC. BAC, that's 42 degrees. We're asked how long the other diagonal is. BD. All right, everyone ready? As I draw it in, shout out some properties here that you may know what's happening here.
Diagonals bisect the
Oh.
angles.
Okay, keep going.
They
Bisect
form.
each
They
other.
Okay, so okay, bisect each other. So that 80 just got split into
40.
40 and
40.
I'll put it over here. 40. Anything else? We're missing one big property.
Four right angles.
Diagonals are perpendicular. And that gets me a right triangle right now. Thoughts on how I can find the length of this entire diagonal? How can I find? You're not going to be able to find the entire diagonal.
You can find the one opposite to 42. Like to angle 42, you can find that.
So you can find part of it. Take a look. Everyone has a right triangle right there?
Yeah.
Can you find this section of that right triangle, that leg? And once you find it, how can you then find the entire diagonal? Because the diagonals they bisect each other. Perfect. All right, so that's your goal right now, everyone. Take this right triangle, solve for that side, double it, and then you'll have diagonal BD. So I'm going to let you guys decide which ratio is the correct one to use, okay? Here. Nice job. Go ahead.
Round when you get the full number.
Once you find the full diagonal, you can round. Like that, I didn't round because I still have to multiply it by 2. So after I multiply it by 2, then you can round it to the nearest integer. And then, all right, a lot of you guys, 36.0, and then you're multiplying it by 2, and you get BD to be to the nearest integer, 72. Okay, part B says find a side now. How are you going to find the side? Emma, go ahead. Oh, which is what in this right triangle? So any ratio that uses hypotenuse, sine, cosine, or if you're feeling crazy, Pythag too. Okay? Figure out which way you want to do now. Sine, cosine, or you could do Pythag. I think I chose to use cosine.
That's a good song.
If you're going to use that 36.016, use the full thing, please. Don't round it to 36. If you, somehow in your calculations you're going to involve that side you just found, use the full decimal.
Done.
Because if you go to one side, you'd just kill it.
And we should have 54.
Oh, we played that last time.
What's it called?
You do this.
54? What'd you do?
I did 72 squared.
Not,
plus 42.
no, Justin. 72 is your full diagonal.
Oh,
You wanted to
yeah.
use the 36.
Okay.
You guys do it.
Finish it right though.
How'd you guys? Did you guys start with the rope?
We eventually decided I wasn't on after the rope, so then we spread it across the whole thing. So we all
Guys, enjoy your break. Take 15 minutes just to get that couple word problems done, and that's it.
Do you have any fun plans?
Me, not during February break, no. Sorry. We're probably going to go somewhere April break, yes. No, we're two kids. Girls are too young, way too young for that. I'll wait till I get my dad's shoes and everything probably to go.
And a lighthouse tattoo?
Yeah, and the lighthouse tattoo as I sit on a bench eating a pretzel. Yeah.